You're building a tower defense game in Scratch. Last time we tried to get the bullets from your tower to disappear when they hit an enemy like this, but we ran into a problem. Sometimes the enemy would ignore the bullet, like this. Other times the bullet would ignore the enemy, like this. To fix this, you'll learn about a simple idea called the game loop, and how to build a game loop in Scratch. If this is your first time here and you want to learn about programming, games, or Scratch, start now by subscribing and clicking the bell so you don't miss anything. Making a game loop is easy. The simplest game loop is only 2 blocks long, so let's jump into it. Remember, the problem was that some block stacks run concurrently, so one stack can get ahead of the other. So instead of building multiple stacks like this, you'll get rid of those and make one special when flag clicked stack called your game loop, which will run your entire game. To get started, create a new blank sprite called game loop. This sprite won't show in your game. It will only contain the game loop code. Add a when flag clicked. This will be the only flag clicked block in your entire project. Broadcast initialize and wait. This will send a message to all the other sprites called Initialize, where they can do their initial setting up. Then in a forever loop, add 3 broadcasts and waits. These will represent the 3 phases of our game loop that will repeat over and over and over again, forever. Each of the phases will run until they are completely finished. For example, the first phase will run, and then it'll finish, and then the second phase will start, and then it'll finish, and then the third phase will start, and then that will finish. We needed to add the and wait to make sure that each phase stopped before the next one begins. You want your game loop to be very fast. Each phase in the loop should run 30 or more times per second. The first phase will be move, where all your sprite clones will move and change their appearance. The second phase will be sense, where your sprites will check is touching. The third phase will be delete, where you might delete some of the clones. Again, this is all happening at least 30 times a second, so it will still look fast. The next thing you'll do is start disabling the original code in your sprites. Disconnect the when flag clicked and when I start as a clone blocks. You'll be updating the rest of your code to work with the game loop approach, so leave everything else there. The pattern you'll use is to add a when I receive block and have it call a function, which you can create inside of the my block section. You will always use run without screen refresh in your functions. It reduces some concurrency problems because it makes your pink function block run all the way to the end before any other blocks can run. For example, when I receive the initialize event, call my function, which I also named Initialize. Here, in this function, do the initial setup like setting star hits to 0. Since you don't have a when I start as a clone block, keep track of whether each sprite is the original or a clone in a variable called clone level. Clone level 0 will be the original tower, clone level 1 will be for clones. Set clone level 0 in Initialize. Only the original will exist during initialization. All the other clones will only be created after the game loop starts. At that point, Initialize has already ran. Since we want our game loop to run really fast, we can't use wait blocks anymore, because those would cause our entire game loop and our entire game to freeze while we were waiting. If you've ever seen this web browser dialog, or this mouse cursor, or this operating system error, or this operating system error, that's what happened. One of your application's code took too long in the main loop, and the main loop stopped running quickly. Instead of using the wait block, you can store the next time you want to do something in a variable, and check it each time through the game loop. The check will be false most of the time, and so the game loop can keep going. Only when it becomes true do you actually do some of your code. Make one of these variables called nextCloneAt. This will track the next time that the original tower sprite should create a new bullet clone. Put the value of timer in it during Initialize. Timer starts at 0 when the green flag is clicked and always has the number of seconds that passed since then. This will mean that the next time you want to create a clone is right now. Now move on to the move phase. Add an if-else. The if will be for the original sprite and the else will be for any clones. You can tell if you're in the original tower if clone level is equal to 0, like this. The original sprite, which represents the tower, will use its move phase to clone itself. Make a function called cloneMyself. Remember to turn on the run without screen refresh checkbox. Add the actual make a clone of myself block. You don't want to do this every single move phase. That would create 30 clones per second. Instead, you only want to do it if the timer has reached the value stored in the nextCloneAt variable. In other words, if timer is greater than nextCloneAt. When that happens, we want to do 2 things. First is to call cloneMyself. Second is to update next clonat to a new time in the future to simulate waiting without actually doing a wait during the game loop. The new value of next clonat will be the wait time from before, plus the current value of timer. Add this to the move handler for the original tower. Next, you'll be moving on to coding the clone bullets, so you need to make sure they get clone level 1. To do this, add 1 to clone level before calling create clone, and then remove 1 again immediately afterward. Here is where it is very important that you click run without screen refresh earlier, otherwise the original sprite might sometimes think that its clone level was 1 instead of 0. By doing this here, you can entirely avoid adding a when I start as a clone block. Move on to the sense handler. You can organize it the same way, where there's space to put code for clone level 0 and a different space to put code for clone level 1. Since the first part of the when I start as a clone code was to set direction, you can create a new variable called direction. Just like with clone level, set it to the clone's value, 45, before you create clone, and reset it back to the original's value, 90, afterward. You'll actually need to call point in direction, so do that for the original in Initialize. Do it for the clones in the move handler. This will keep all the blue code together in the move handler. The next moveAt variable will be exactly like the next cloneAt variable, to avoid calling wait between calls to move. Set it to a random time in the future, and only go through with moving if timer has risen above it. In the sense handler is where you will look at touching Goblin. If it is true, then add 1 to star hits just like before. But instead of calling delete clone directly, since that might prevent the Goblin from detecting the star, make a new variable called delete me, and set it to 1 to represent yes, delete me. 0 will mean do not. The last event stack is the delete handler. You only want something to happen here if delete me is 1. And the thing that you want to happen is actually deleting the clone. Test out the code and the star's behavior looks like it does before. But now, it doesn't use when flag clicked or when I start as a clone, and because of that, it'll have fewer concurrency problems. The Goblin code will be pretty similar to the star code, so delete all of the Goblin code, and copy all of the star code into the Goblin sprite. Make sure to switch all the star and Goblin references in the Goblin code. Oops, missed one. There we go. Now as you can see, both the star and Goblin detect that they're touching each other, and both of them delete themselves each time, so your star tower is no longer too overpowered. If you think this game loop idea might be useful for you, leave a comment saying the word yes. If you like this video, please press the thumbs up button and consider supporting more videos like this one by subscribing to the channel and turning on the bell, and watching some of the other Game Titan videos on programming, games, or Scratch. Thank you for watching, and see you next time.